Most days, I get to joke around and explore the odd corners of history and science. Today's list is not that. Researchers keep publishing findings that paint a tough picture of what's happening out there in the natural world. And if the people who study this stuff for a living are sounding uneasy, the rest of us should probably pay attention. From the browning of our freshwater lakes to traveling fungi and severe deformities in certain animals, I'm Mike with List 25, and these are 25 disturbing changes in nature scientists are watching closely. 25. Deformities in Arctic wildlife. In early 2026, marine biologists surveying pink salmon runs in northern Norway pulled up several adults that stopped them cold. The fish had sharply bent spines, compressed vertebrae, and body shapes so distorted that they could barely swim. The same thing showed up again when researchers from the Institute of Marine Research sampled additional rivers along Troms in Finnmark. Every new site revealed more adults with the same severe deformities. Per Gunnar Fjelldo, one of the lead scientists, has spent years studying skeletal development in fish, and he and some of his colleagues now suspect that rapid environmental changes in the Arctic are interfering with the early growth stages of these salmon. That region is warming 2 to 3 times faster than the global average, and the changes in water temperature and food availability line up with the deformities appearing in multiple populations. 24. The acceleration of global extinctions. Have you ever heard of the 6th mass extinction? Well, we're living it. The 2019 report from an organization called IPBE has warned that nature is declining faster than anything humanity has ever documented. Almost 1 million species could disappear within the next few decades. It's happening so quickly that our current safety net supporting food, water, and economies is starting to break apart. One review found that native species in major land habitats have dropped by roughly 20% since 1900. While more than 40% of amphibians and a third of marine mammals are now threatened. The biggest culprits? Land and sea use, exploitation of species, climate change, pollution, and invasive organisms. Still, the IPBES team has stressed that none of this is set in stone. They argue that countries can slow the damage, but only with rapid, coordinated action. Without it, the decline will continue. 23. The browning of our freshwater lakes. When scientists study lake health, they often begin with something as simple as its color. A global survey published in Geophysical Research Letters used millions of satellite images from 2013 to 2020 to see how the world's lakes actually look from above, and it confirmed that true blue lakes make up less than a third of all freshwater bodies on Earth. The researchers found that warming temperatures, changing precipitation, and longer ice freeze seasons all encourage lakes to drift toward green or brown tones. There's also a well-documented link between warmer water and increased algal growth, which helps explain why many lakes in North America and Northern Europe are losing their blue color. A few studies point to sediments and basin depth playing a role too, but those influences tend to be smaller and more local. 22. The collapse of the Atlantic currents. A group of 44 ocean and climate scientists recently released an open letter at the Arctic Circle conference in Iceland describing new evidence that the Atlantic meridional overturning circulation may be weakening faster than earlier assessments suggested. This is the system of currents that moves heat through the Atlantic, and several recent studies, including work from the University of Copenhagen, now point to a possible collapse within the coming decades, rather than some time after 2100. There have also been studies by the University of Potsdam that show unusual behavior in the long-term records, enough to suggest that the circulation is becoming unstable. If this current keeps slowing, it'll transform our weather, coastlines, and ocean life in ways that none of us are ready for. 21. The Sargassum Explosion. For most coastal regions, seaweed used to be nothing more than an occasional nuisance. That changed when researchers at the University of South Florida started tracking what they now call the Great Atlantic Sargassum Belt. Their satellite work showed that the annual mass of this floating seaweed wasn't just growing, it was exploding. Seasonal peaks have pushed past 30 million tons, with some Caribbean shorelines receiving more than 100,000 tons a year. Weirdly enough, though, open ocean sargassum serves as habitat for plenty of marine life. It's only when those giant mats hit the beaches that it becomes a real problem. Tourism collapses, fish nurseries take a hit, and cleanup costs climb into the millions. 20. Unprecedented sea urchin mass die-offs. Marine biologists first noticed something was up when routine reef surveys across the Caribbean showed sea urchins disappearing almost overnight. Teams in the Virgin Islands, the Eastern Mediterranean, and other regions compared notes and realized the same thing was happening in waters thousands of miles apart. Healthy urchins one month, empty shells the next. Most people assumed it was a local contaminant or a single outbreak. That theory collapsed when the Red Sea reported identical losses. Once researchers began testing the dying urchins, they kept finding the same culprit. Each one carried a heavy load of a ciliated microbe that attacked their outer tissue and spread faster in warmer conditions. And every time the urchins vanished, the result was immediate. Algae swept over the reef before the coral had a chance to recover. Some sites have stayed stuck in that algae-dominated state for years, which is why researchers are treating these die-offs as a serious long-term threat. 19. The rise of zombie wildfires. In 2024 and 2025, wildfire researchers tracking burn areas across Canada and the western United States noticed that several of the record-breaking fires never fully went out. They smoldered underground through the winter, buried in peat, and then flared back up once the weather got warmer. Those holdover blazes, now called zombie fires, come with a dangerous side effect. When they burn through old mining regions, they release stored toxic metals into the air, adding to the massive smoke plumes that already drift across whole continents during fire season. These fires make the air quality far worse and slow forest recoveries down long after the surface flames disappear. 18. The migration of pathogenic fungi. For decades, the most dangerous fungi stayed close to the equator because they couldn't tolerate much heat. That's changing. As global temperatures rise, several pathogens, including Candida auris and a range of crop-killing rusts, have started moving into cooler regions. Scientists say the real worry is how quickly they're adapting. A fungus that can shrug off higher temperatures is far more likely to survive inside the human body, where fever used to be a built-in line of defense. Farmers are feeling the strain too. Once these fungi get established, crops like bananas and coffee become far harder to protect, and entire harvests can fall apart in a single season. 17. The global spread of forever chemical rain. A chemical called TFA, or trifluoroacetic acid, part of the forever chemical family, is now showing up almost everywhere scientists look. It forms in the atmosphere from industrial compounds, then falls back to Earth in what we know as chemical rain. Because TFA doesn't break down, it builds up in the soil, rivers, and even polar ice. The concern isn't just persistence, it's how the accumulation is spreading through crops, drinking water, eventually the food chain. Every season adds a little more to the global supply. 16. Global marine heat waves and coral die-offs. Ocean scientists entered 2024 and 2025 hoping for a break, but the opposite happened. Sea surface temperatures shattered every record on the books, pushing the planet into its fourth global coral bleaching event and the most intense one we've ever measured. More than half of the world's reefs lost their color as corals expelled the algae they rely on for food. Once that partnership breaks, the corals begin to starve, and the entire reef community starts to unwind. Fish numbers drop, habitats collapse, and in some areas, the rubble fields left behind can't regenerate quickly enough to keep up with the heat. What happens next depends largely on how quickly the water cools. Some corals can recover if conditions improve, but repeated heat waves make that window smaller every year. Several regions have been hit so often that scientists worry the reefs won't bounce back at all. And when those weakened corals get buried under drifting sargassum mats, as we saw in the Caribbean, the damage only accelerates. 15. The rapid decline of alpine biodiversity. Glacier mice look like moss-covered stones from a distance, but each one is a soft living bundle that shelters its own community of microscopic species. Field teams in Alaska, Iceland, and parts of the Andes have watched these tiny habitats shrink as melting accelerates. Some glaciers that once supported thousands of mice now have only scattered patches left. The loss goes far beyond the mossballs themselves. Glaciers regulate river flow, irrigate farmland, and sustain alpine ecosystems that never evolved for warm temperatures. As the ice retreats, the species tied to those cold, stable conditions start slipping toward extinction. 14. The expansion of oceanic dead zones. Dead zones sound dramatic, but the science behind them is painfully straightforward. Nutrient runoff from farms fuels runaway algae growth. When that algae dies, it sinks and decomposes, a process that consumes nearly all the oxygen in the surrounding water. Anything that can swim out will, and anything that can't is left behind in a landscape that looks more like a desert than a coastal ecosystem. The problem is getting worse as ocean temperatures rise. Warm water doesn't hold oxygen well, which means places like the Gulf of Mexico and the Baltic Sea experience sharper drops each summer. The only reliable fix is reducing runoff at the source, but that's a long process with a lot of global moving parts. 13. Tropicalization. One of the more obvious signs of warming oceans is how quickly tropical species are showing up in temperate zones. Scientists call it tropicalization. Rabbitfish, for example, have moved into the Mediterranean and parts of Australia's southern coastline. They graze with an intensity the native herbivores can't match, chewing through kelp forests and seagrass beds that normally anchor entire coastal ecosystems. When this structure disappears, algae take over the empty space, spreading across the sea floor and crowding out these slower-growing native species. Fisheries tied to temperate species notice the shift first, because the fish that depend on cooler, structured habitat either move on or shrink in number. All in all, these rearranged communities are a strong indicator of what our seas will look like in the decades ahead. 12. Mass die-offs along migrating routes. Every year, thousands of migratory birds attempt to cross desert belts that used to offer them pockets of shade, water, or insects along the way. Those stops are disappearing. Heat waves now hit earlier and last longer, and a lot of the small wetlands or springs these birds depended on have dried out completely. And when these large die-off events are investigated, they always find that the birds simply ran out of water and energy mid-flight. Scientists describe these routes as death traps, because the birds don't know the landscape has changed until it's too late. And the ripple effects reach far beyond the desert. Many of these species play critical roles in pest control and seed dispersal in the regions they migrate to. So losing them means fewer natural checks on insects and slower recovery for the vegetation. 11. The silent spring effect. Surveys in Europe and in parts of the United States have shown sharp drops in flying insects, sometimes more than half of what was recorded a few decades ago. What makes the problem worse is the timing. Warmer winters push certain plants to bloom early, but many pollinators still appear at the same time they always have. By the time they arrive, the flowers are already past their best. That mismatch spreads through the whole system. Birds that raise their young on insects end up short on food, and several species now show lower numbers during the breeding season. Economic groups are paying attention too. The World Economic Forum now lists biodiversity loss near the top of global risks because it disrupts farming, wild ecosystems, and the basic cycles all of us rely on. 10. The carbon cycle. You still with me? This one is a bit weirder. The soil is acting up. Every handful of Earth is full of microbes that help lock away carbon, and under stable conditions, they do it quietly and efficiently. But experiments from field plots and climate chambers show that as the temperature rises, those microbes start burning through organic material faster. The result is a noticeable jump in CO2 being released back into the atmosphere. Several global mapping projects are now underway to see which regions are most vulnerable and whether land management can stabilize these communities. 9. The greening of the Himalayas. The word greening usually sounds like good news, but the scientists studying the Himalayas will tell you a different story. Over the last few decades, shrubs and hardy grasses have been creeping higher into terrain that used to be mostly ice and snow. Dark vegetation absorbs far more sunlight than bright snowfields, so once the plants settle in, the surrounding ice melts even faster. It's a genuine crisis because the Himalayan glaciers feed the river systems that are relied on by nearly 2 billion people. Any change in how that meltwater behaves hits communities from India to China and all the way to Southeast Asia. 8. The homogenization of global flora. You don't have to climb the Himalayas to see how plant communities are losing their identity. The same trend is playing out at lower elevations all over the world. In many regions, a small group of generalist plants is spreading into places that once had far more specialized vegetation. These newcomers grow quickly, tolerate rough conditions, and crowd out the slower species that give each ecosystem its own character. Once they settle in, the food web starts to wobble. Pollinators start bypassing the areas because their preferred plants are missing. Ungulates avoid patches where the new vegetation offers little nutrition. Even soil conditions change. The landscape doesn't collapse all at once, but it quickly becomes a stripped-down version of what it used to be. 7. California's kelp forests. In 2014, a long, stubborn marine heatwave parked itself off Northern California and cut off the cold, nutrient-rich water that bull kelp needs to grow. The forest collapsed in a single season. What made it worse was that a sea star wasting disease struck at the same time, wiping out the main predator that kept purple urchins from overrunning the reef. With the stars gone, the urchins ate through what little kelp remained. Now scientists are watching the coastline like hawks. They're tracking how often marine heat waves return, how quickly urchin barrens spread, and whether recovering sea star populations or sea otters can put enough pressure on the urchins to give new kelp a foothold. 6. Toxic dust storms. Lakes that once covered huge areas, like the Great Salt Lake and the Aral Sea, have pulled back so far that wide stretches of lake bed now sit exposed. Those dry flats aren't harmless. They're packed with sediments that collected metals and old farm chemicals over decades. And when strong winds sweep across them, the surface breaks apart into fine dust that blows straight into nearby towns. And that's where the problem comes in. Tests from the Great Salt Lake show that this dust often carries higher levels of arsenic, lead, copper, and other metals than typical desert soil. Because of that, research teams are now taking regular samples to understand how quickly the hazard is growing as these shrinking lakes expose more contaminated ground each year. 5. Increasing nighttime heat stress in crops. Daytime heat waves might get all the headlines, but scientists are deeply worried about rising nighttime temperatures. Crops like rice, corn, and wheat need cool nights to recover and breathe. When the nights stay hot, the plants consume the energy they stored during the day, leading to significantly lower yields and poorer grain quality. The studies they've done on rice are especially blunt. For every single degree of nighttime warming, yields can drop by roughly 10%, and the grains themselves tend to come out smaller and lower in quality. So our nighttime heat could end up deciding how much food we're able to grow in the years ahead. 4. Cloud forests. Warm air holds more moisture, and that simple fact is rewriting the future of cloud forests. A warmer planet means the clouds form higher now, leaving many mountaintops below the fog line. And once the mist stops brushing the canopy, the forest dries out fast. Epiphytes fade from the branches, bark loses its usual moisture, and amphibians start disappearing. You also see things like orchids and moss layers thin out in the areas where the cloud line is pulled away the most. It also means that as these forests lose moisture, their streams lose part of their usual flow. And because millions of people rely on that mountain runoff for drinking water and farming, the change isn't just a conservation problem. It's a direct threat to everyone who depends on those rivers. 3. Noise-Polluted Seas. Rescue teams along several coastlines are seeing more whales show up in places they were never meant to be. This is not a navigation failure in the traditional sense, but more that the water itself is louder than it used to be, and sound travels through it differently. Melting ice has opened up new shipping routes, and warmer surface layers can carry noise much farther, which means the calls whales rely on to stay in touch get buried under the background roar. Even fish and drifting larvae, which don't communicate anything like whales do, depend on subtle reef sounds to guide them back to the right habitat. When that signal disappears, they scatter in every direction. With strandings and missed migrations becoming more and more common, several marine labs have started pushing for more stringent sound limits in the busiest parts of the ocean. 2. The decline in earthworm populations. Now here's something I didn't think I'd ever talk about on this channel, but yes, our earthworms are disappearing. In the UK alone, long-term monitoring shows their numbers down by about 1/3, and similar declines are showing up in other farming regions. Now that wouldn't seem like a big deal on face value, but once the worms go, the soil loses its natural ventilation, drainage, and nutrient cycling, which means crops struggle no matter how much fertilization you throw at them. According to Ailey Burns at the British Trust for Ornithology, the biggest pressures on earthworms right now are constant pesticide exposure and soil that's been pushed past its degradation limits. 1. The Lost Cooldown. Okay, I know we spoke about crops and heat stress at night earlier, but this is the bigger, uglier version of that same story. For decades, the planet relied on darkness to cool itself. Now the heat barely drops after the sun goes down. Greenhouse gases work like a heavy blanket. Cloud cover traps whatever warmth is left, and the nighttime reset just disappears. Climate Central has been tracking this for years, and their 2024 data shows those hot nights spreading into regions that never used to deal with them. And the fallout is everywhere. We've got more heat-related deaths, more stubborn wildfires, and visibly stressed wildlife because there's no cool window left in the daily cycle. When the nights stop giving us a break, everything from ecosystems to basic human health stays under strain long after the sun goes down. And that is everyone's problem. Alright, that's where we'll stop for today. But before you head out, tell me, which one of these changes is something you never even thought about? I love seeing what jumps out at you guys. And if you're up for some more, today's related video is 25 warnings from nature that signal disaster is coming. You'll see how storms, quakes, and even odd animal behavior can give you a heads up long before anything terrible makes the news. The link to that one should show up right about here. And as always, thank you guys so much for being here. You truly make these lists worth doing. Also, like, share, comment, subscribe with that notification bell, and I'll see you next time.